The traversals so far dive deep into one branch before moving on. Level order is different. We read the tree the way you would read it on paper. The top level first, then the next level, then the next. This is a breadth first walk. Let's see how we do it without recursion. The tool here is a queue, a first and first out line. We start by putting the root in the queue. Then we repeat. Take the node at the front of the queue, output its value, and add its left and then its right child, if they exist, to the back of the queue. Because children always join at the back, a whole level is fully processed before the next level begins. That is why the values come out top to bottom, left to right. On our tree, it gives 1, 2, 3, 4, 5. If the tree is empty, we return an empty list. Otherwise, we start a result list and a queue holding just the root. While the queue is not empty, we take the node from the front, record its value, and push its left child and then its right child onto the back of the queue. When the queue drains, every node has been visited in level order. Let's build level order with a queue and run it on the sample tree. Handle the empty tree, then set up a result list and a queue holding just the root. While the queue has nodes, take the one at the front and record its value. Then add its left and right children to the back, so they are visited on the next level. When the queue empties, return the values gathered level by level. Now let's test it and hit run. There it is, 1, 2, 3, 4, 5. We read the root first, then the whole second level 2 and 3, then the third level 4 and 5, exactly top to bottom. Here is the loop. We start with the root in the queue. While the queue is not empty, we take the front node, output its value, and add its children to the back, then loop again. When the queue is empty, we return the collected values. Each node enters and leaves the queue once, so the time is order n for n nodes. The space is order n as well, because at the widest point the queue can hold an entire level of the tree, which can be up to about half the nodes. 3 reminders. First, this needs a queue. Always take from the front and add to the back so levels stay in order. Second, check that a child is not empty before adding it. Otherwise, you push none into the queue and crash later. And third, popping from the front of a plain list is slow for large trees, so a dequay from the collections module is a faster choice.